So in this video, we want to take a quick kind of introduction into recursion. And recursion is a kind of repeat structure. So we're going to be comparing recursion to for loops. And so here's an example of a program where we can kind of, I'm not sure if you can see the difference. It's not that obvious, but we have two different types of patterns here. And this pattern is interesting because it has a cutout first off, so we can actually see through, the cutouts to see the shapes more effectively. This one doesn't have a cutout over here. What's happening over here is a pattern that's kind of using a for loop, and what's happening over here is a pattern that's using recursion. And recursion, we're going to learn, has this stacking behavior that happens when the code's being executed. And we can take advantage of that when we're creating patterns if we want an interesting pattern, because we can stack something in both directions essentially. So we can go from large to small and small to large all within a single function. And that is much more difficult to do with a for loop. So recursion is this self-similar process. It's what fractals are basically use recursion. So I want us to get a feel for what this looks like. And the best way to get a feel for it is to be looking at these P-shapes that have a cutout, because when we flip the size of the thing that when we flip the shape, if we start out with a normal pattern, we want to draw the largest shape first, and we would end up with the smallest shape last. Well, with recursion, we can flip that, and so we can have both the smallest and largest kind of stacking orders. So if we're going to have a stacking order where the smallest one is drawn first, we want to have a cutout so we can see through and see that. But we can tell it gives a really complicated and kind of beautiful, it's a more natural organic pattern with this natural mirroring asymmetry. Okay, so that's where we're going. And so we want to start by looking at the this idea of a P-shape with a cutout. And so on the Git book, it's called a contour. Okay, so I'm at this P-shape with contour, and I've got some examples here. I think I briefly walked through that last time. So once again, we're just making a P-shape again, and we're essentially specifying out our points. And once again, we want to do it on a grid. I recommend a grid that's like 10 by 10. This one's a little more complicated, especially with a shape like this. It would have been easier if it was a 10 by 10 grid. But anyway, so I'd had the initial points, the outer points, going in clockwise direction, and then I came back to the starting point and I made a little cutout, some points on the inside that had to be rotated in the opposite direction. So this was the first set of points that create this outer P-shaped form, and then we use this processing function called begin contour, and then we specify the points, the inner points. And sometimes you'll end up wanting to repeat the start point. Sometimes you don't need to. We'll get some weird behaviors with these contours and cutouts, so that's totally fine. So I'm repeating that same point, but then I'm going in a counterclockwise direction. And then I have to use that end contour function, and then once again end my shape like that. Okay, so if we look at the code, what you'll see here is we're just kind of getting the general idea. This is like the pseudocode. But if we look at the actual code, right, this is one of the custom functions that you're creating, right? This function is going to return a P-shape. So we're passing in width and height and a color. And we create our P-shape. We're going to use our vertex points. And so once again, each time we set a vertex point, we use this S is the object, the P-shape object, dot notation, and then it lets us call a function that belongs to that object. So we call begin shape, specify our vertices for the outer form, then we call this begin contour, and then we specify our vertices for the inner cutout, then end contour, then end shape, then I went ahead and said, let's set the fill now, and then return that P shape. So this should all look really comfortable for you guys. So we're going to keep playing around with these P shapes. Okay, and then there's another example here. In this example, when I give the code, this code is not actually in a function. So please pay attention. This would you'd be able to use this code. Well, you basically need to put it in a function. You could put that in the draw loop if you wanted to, or in setup, because here's the line of code that's actually rendering the shape. Okay, and here's kind of a fun pattern that I created doing that. Okay, so if we come back here, once again, we looked at, this is kind of the pseudocode of figuring out, what's the coordinates for point 1. Well, this is the width. So I'm at the 0 point on that grid, right, for the width. So point 1 has the width times 0, and then the height times 0.25. Okay, so we, and actually I repeated that same point several times. Point 1 and point 6 are the same. Okay, so then what we want to also do is we're heading into this idea of recursion, and we want to use recursion for what we're doing to have these kind of gradiated shapes. So we want to look at different ways that we can create this kind of linear change or some functional change each time we call this, each time this pattern gets repeated, we want to be making some small change. So the map function is going to help us have, instead of a random change or a random value, we want to have something that's more sophisticated. So the map function is going to allow us to do that. So the map function once again says, hey, we have values in 2 different ranges, right? Range 1 has a minimum and a maximum value, and this could actually be like the maximum, this could be the minimum. It doesn't really matter. I'm just keeping it simple. So within range 1, right, we need to know what is the min and what is the max value in that range. These are the values that we know. So when we were doing the mouse, we would say that the known value in the starter range would have been like 0 to width if we were doing the mouse X. We can imagine that, right? The mouse, where is it from the left hand 0 all the way to the width? But what we're going to do is something different, because we're going to be doing this repeated functions, repetition. So we're going to be using a counting variable. So I'm going to say that we have this counting variable that we know will be changing. So with each time that we have a new instance created, the count is going to be decreased. We're going to pass into the function a large value, and then we'll keep making that smaller. So we're going to pass in the max value or some value in that range. We do need to have this specified. So I've been making this max count a global variable. We'll see why. And so then at any point when this counting repeat is occurring, it will have some value. And what we're going to want to know is, can we map that to something useful? And so we're going to just play around for now with fractions, because we're going to be using scale. We're going to be making the shapes smaller and larger. So fractions work well for that. We'll also be using lerp color. And we'll also learn another way that we can kind of just use this mapping of a known range, the count, to a fractional value. And we get to choose, what's the range of values in that fraction, and that'll change in the different examples. But I want to, as we kind of go through the more advanced recursive examples, I want to make sure you guys can come back and understand how this map function is working, how we're using it. So we get to specify any of the values here. We get to specify this. What's convenient for us? And I'm suggesting that fraction is a convenient value for scale, and we'll figure out a way to use it to modify the color. Okay, so the way the map function works is we're calculating a value, and it's a float. and we pass in the known value, so I'll say that's the current count, and then the range within this range 1. And so it's either whatever 0 to the max or 1 to the max or whatever, and then whatever we're choosing here. So in this case, it looks like as the, if the count were starting at 0 and increasing, then we'd have the size starting large and going small. So we want to keep thinking about that we can play with these ordering of these values as well. Okay. So then let's go ahead and take a quick look at, that was our recursion preview. This is our P-shape with contour. So once again, this is the code that's creating this fall shape. I call it a fall shape. And there's one other type of P-shape I want to show you, and that is P-shapes where we can actually have a group. Okay, so we can have a P-shape that contains multiple child P-shapes. We're not going to use that quite yet on this project, but as long as we've talked about the P-shape with the contour, I want to go ahead and talk about P-shapes with groups. So pay attention here. Once again, this is a function that's taking in width, height, and color, and it's going to do some logic here to create and return a P-shape. So these are these custom functions to return a P-shape. But in this case, I'm going to start by saying that I'm going to define 3 different P-shapes. The first one, I use that create shape, but I pass in the term group. And that means that this is a special parent P-shape that can have child P-shapes added. So this group P-shape is the one that's going to be returned. And so we declare that P-shape, then we create our other P-shapes. Now I could, in this example, I'm just calling the functions up here for these simple shapes. So this is just a simple P-shape custom function, passing in these same parameters that we keep using those parameters. This added another parameter on this rectangle primitive so that it's rounding the rectangle. So if we were to create a rectangle with 5 parameters, that last parameter does rounding. And then since we're passing in the color, we always are going to set the fill, but we'll be often changing that fill. Okay, so we have a simple function that creates this rounded rectangle, and this is the function that creates that cutout. Now with this group P-shape, right, I called it a parent P-shape. That's what's returned is the parent. We're passing in the same parameters, and we're passing those parameters along to the functions. Okay, so the function, this first function, I have to pass along a width, height, and a color. But then I decided after that shape's been created, I'm going to change the color to basically a gray transparent color. So I'm overriding this C1. So that's just, we do a lot of playing around with color here. Okay, and then I had some ideas about how we could calculate a contrasting color if we wanted to. Right, with any color that is passed in to get the contrasting color, right? We would just say, well, what's the hue for the current color? And then we'd add 180 degrees and take the modulus of 360 to make sure that it was a value between 0 and 360. And then we would use, whatever the current brightness and saturation are. Okay, so the idea was that we're calling our custom functions to make these child shapes, and then we use this method add child. So to the parent P-shape, that's an object, it can call a method add child, and then we pass in those 2 methods. And the order we pass them in does matter. It's the stacking order. And then so we can have complicated P-shapes. A P-shape is essentially an SVG file format, and so you can imagine, the SVGs that you could create in Illustrator, right? Okay, so let's go ahead and see. We just have, right now all we have is up in setup. I've defined some colors, and this very max count we won't use yet. So we just have our initializing the colors. I set the color mode to HSB. And then we're just going to create the first contour with the cutout, see what that looks like. I just call the function, and then I have to render it, and I'm deciding to render it at the point 100, 100. And then for the second one, this parent P-shape, right, passing in the same type of values, width and height, and then I'm just using this other color and rendering it at the origin. So let's see what that gives us. Okay, so we can see that I have kind of this lime color is what I passed in up here. Okay, so this is basically the cutout. And then if we look down here, when we're calling that parent shape, essentially what we're doing is we're getting that rounded rectangle, right? So that's the rounded rectangle that's essentially width by height. So we can actually see the grid. Okay, so that's just giving kind of an example of this contour, complicated P-shapes with a contour, complicated P-shapes with groups. The thing with the group P-shapes is that if we wanted to change the color, we'd have to unpack them and set the color. So we're not going to be working with those as of yet. We'll get to that at the end of the semester probably. Okay, so then let's go ahead and do a quick look at what recursion would look like and what a recursive function would look like. We're just going to keep repeating this, but this is our first look. So for recursion, we have this idea of a function that essentially is going to call itself. So the definition of a recursive function from a programming perspective means that we have a function, we're specifying the parameters, and yet someplace inside that function, we call the function itself, and we are passing in, as parameters, some modified values. So it's critical that at a minimum, we need to be modifying this stopping condition. We'll say this is our termination, this count, how many. So because this is a looping structure, every looping structure has to have a termination condition. So we're going to just really quickly make a super simple recursive function. I'm just calling it recursive pattern. Once again, passing in a P-shape. This is the count. How many times do I want that repeat? And then the color. So the most important thing anytime we have a repeat structure is to ensure termination. So in this case, we'll just say if count is less than 0. And the way we're going to terminate this is just to say return. So no code will get executed if this test case is true. So we're always going to come in and check, do we need to stop or can we continue? Okay, so this is, we'll look and see, this is also what we would consider as the base case in kind of the mathematical way to look at recursion. So we always want to ensure termination. And then essentially we have a pattern structure, right? We have a structure that's causing, that we want to cause a repeat, but then we also have a task that we want to have done. Just like a for loop, in a for loop, you're going to want to have some task that you're executing, right? It's repeat something. And the task, that's what I'm saying, is the something. So in this case, we're going to call we're going to pass in the shape. We want to render that shape. And then calling the function, we are going to just pass the shape along. We're going to, we'll play around with passing the color. How are we going to change the color each time? And then this is the most important. We need to be making sure that that count value gets reduced so that each time we call this function, the value that we're using for termination is always going to be heading in that direction, right? So if we're, so anyway, so we're reducing it by 1. So now for this, this change logic, because we want a pattern, we want to have these things getting smaller, we want to maybe change the brightness, we're going to use the map function. And so I've got a little logic down here. I'm just going to grab it. Oh, I don't have the logic down here. Okay. Well, that is okay. Okay. Well, we'll go ahead and say that we want to create a a float, and we'll call this our scale factor. And we'll use the map function. And now in this program, I've defined max count as a global variable. That's because when we call a recursive function, we don't ever know which time. So we can't use this value of count because that's changing. So count is the value that's changing, and it's changing in a range that starts with max count, because we're going to, when we call this function, we're going to pass in that max count. Okay, so this is the map function again. So count is the value that's changing. It's changing in a range that's, I'm going to say it's starting at the max count, and then we'll say it goes to 1. And then we want to have that control a value that goes from 1 to, let's say, 0.5. And we'll use that for the scaling, right? We'll imagine that when the count is largest, we want the largest shape. So the largest shape will be rendered first. Okay, so then we're going to use this scale factor. So what is important is to understand how this scale factor is going to be impacting these shapes. So we'll say that we want to have the scale factor. Okay, right, so it's multiplicative, so that we can see that when the count is at the largest, we'll have the largest shape, and that'll happen first, right? So largest to smallest, and each time we're going to set that as the size of the shape. After we render the shape, we need to reset the matrix, or the shape that we pass along will be smaller. And we don't want to do that in this case. But let's go ahead and do one more thing, and that is, let's go ahead and set the color. So we have this color C1. Let's make another color. We'll call this cur color. And let's just say we want to do the hue, the C1. We want the current hue. We want the current saturation. And then we'll just change the brightness. Brightness C1 times, and now this will be another way to do it. We're just going to say each time we do this, so let's multiply it by 0. Let's say 9. Okay, so each time the brightness, we're just reducing it by a factor, and then we'll just have the alpha. And maybe we'll do the same thing. We'll multiply it by 0.9. Okay, and so we're looking at two different ways to have logic that's going to make changes to how this is rendered each time. So s.set fill. Okay, so I'm using that color. And now here, what I'm going to do is, instead of passing along the color as it is unchanged, I'm going to go ahead and pass along, the next time we call it, we're going to call it with these reduced values of brightness and alpha. So we'll pass cur color. So recursion is always this idea of taking the current state of something and then making a small change along some dimensions of whatever that current state is. It's essentially the growth pattern of life, and that's why we're going to spend this whole assignment looking at recursion, because it's so important for you guys to get the feeling of what recursion is, because you're going to be using it in a lot of the designs and structures that you guys create. Okay, so now we have this task that's happening, and then we call the function again, and that I'm telling you that calling a function again is going to create this this repeat structure. It's a little harder to understand, but when we look at it, we can see that if I got rid of that, right, it would kind of be like one of our other patterns that we've been working on. But instead, we're going to use this feature of recursion to create our pattern. Okay, so now in draw, I'm going to come up here and just say, right, once again, we want these functions where we can pass in any P shape, and we want to get some pattern. Okay, and the pattern that we would expect would be that it goes from large to small. Okay, and I'm going to go ahead and comment these guys out. And we need to do a translation. And then we'll do a reset. Okay, so now when we call that, hopefully we'll get, we're not really seeing that. Okay, so the last time I tried this, I actually was calling these parameters in the incorrect way. I have to match them up with how they're defined up here. And what we don't see, we should have expected this to give us an error, but the colors are actually considered an integer. So when I was saying the order I was calling it in was the shape, the color, and the count. And these are actually both integers. We don't see that that's an integer. But anyway, it would have given us an error if I had been... Anyway, so I'm lucky that that didn't cause a termination or cause my computer to crash. Okay, so now I want to do count. Okay, so once again, I want to be calling the function itself, matching those parameters, and making sure that I have change in the parameter that is controlling the termination. So the color, we're deciding to pass the color along as a changed value. But the P shape itself, we're not. We're actually saying reset matrix. If I don't do reset matrix, in fact, let's do that one time and see. So let's see what we have. Okay, so what we can see is we have this cutout shape, and we can tell that the shape is darker each iteration. There's 5 of them. The largest one was printed first, right? Was rendered first, and then the brightness was decreasing. Okay, so let's try this. Let's not reset the shape, and so we have one shape in memory, and that looks pretty cool, actually. So each time the scale that we pass along, each time the scale of the shape reflects the last scaling that we'd had. So it kind of is a compounding factor. Okay, so this is, like I said, this is our first look at recursion, and it's a very elegant thing, and so we want to kind of take advantage of the elegance of this. In fact, what is also cool, we'll see that the structure of a recursive function really gives us a lot of ability to have this kind of custom complex patterns created. Okay, so we'll stop there.